Welcome back. You're in the right place if you've done the CRISPRkit dual color experiment and have waited 16 to 48 hours for a reaction to proceed. We will now talk to you about the next steps and how you can use a tool developed by us to analyze your results and determine whether CRISPR worked for your experiment. We developed CRISPectra, a simple yet versatile algorithm to allow you to quantify the amount of pigmentation in your reaction tubes so you can analyze how well CRISPR has done in repressing the genes in your tubes. Refer to our website and paper for detailed documentation and code for CRISPectra, both of which are linked in the description. But essentially, as tubes give off a certain pigmentation or observable color, we can first extract its raw RGB values. Then, from this 3D color model, we dimensionally reduce it into a singular representative value. So in the case of the dual color experiment, each reaction will have a red value and yellow value associated with it since we are measuring the pigmentation levels of the red and yellow chromoproteins. Traditionally, to analyze the pigmentation of fluorescence levels of genes, we have to use a plate reader, which is expensive and inaccessible to many. With CRISPectra, we can now achieve highly accurate approximations of gene expression levels at a low cost, and anyone with internet access can analyze their CRISPRkit data for free. Okay, so now that you have a general understanding of what CRISPectra is, we will use it to analyze the experiment you did. As you can see, on the CRISPectra webpage, you have to fill in a couple fields: your name, your organization or school, and as we only have one version of our kit right now, the dual color kit, which you did, we'll select that, and then you put in the image you took of the experiment, and this page will pop up. And as you can see, there's a couple image pre-processing tools you can have. You can adjust the brightness. We recommend you adjusting the brightness a little bit, make it a little bit dimmer to avoid, to get rid of the glares, make it less prominent. And then for contrast, we recommend you maybe to up it by 1 or a little bit so that the colors are more distinct and better for the CRISPectra algorithm. And then you go in and mark out the regions that you want to analyze. So the first tube, which is the red only condition, control condition, you add a circle and then mark the region in there. So something like this. And then we'll move on to the second tube, the yellow only control condition, positive control condition. Once again, we'll mark out the circle, and we'll do it for the rest of the conditions. Once you're done marking out the 7 regions within your 7 reactions, CRISPectra will take in the regions that you marked out and do expression analysis. So once it looks good, you can press submit. So once you press submit, the results page will pop up, and as you can see on the left here, that's the image you uploaded, and on the right on top, you will have the conditions, the raw RGB values, which I talked about in the CRISPectra algorithm, and once it does its dimensional reduction, you will have the red percentage, the red expression values, and the yellow expression values. And on the bottom here is the graphs associated with these values, the red and yellow values, and we'll now go through these values a little bit. So for the red only control condition, the red value is normalized to 100 because that is the maximum expression level. Similarly, for the second tube, the yellow only control condition, the yellow value is normalized to 100 as well because it is the maximum expression level for the yellow gene. All the other conditions will have the red and yellow values with respect to the control conditions. In tube 3, which is the red plus yellow control condition, we expect the two values to be approximate. Due to resource limitation in a cell-free system, both values would definitely be significantly lower than 100, which is observed in their respective single color control conditions. Here in our experiment, the red seems to be lower, meaning maybe the yellow is overexpressed or red did not express as much color. Moving on, the results are really good for the CRISPR repression conditions. As expected for the red targeting condition in tube 4, the tube only shows yellow, as you can see here in the original image, which is also reflected on the graph, as you can see how yellow is really high while there's no red value associated with it. For the yellow targeting condition in tube 5, the tube only shows red, as you can see here in the original image as well. And on the graph, we can see there's negligible yellow expression with pretty high red expression value. For the both targeting condition in tube 6, as you can see in the original image, it is pretty much transparent. And moving back to the graph, both values, red and yellow values, are pretty much the same as the negative control, the no color condition, which is close to 0 as well. So it indicates strong repression on both colors. So based on our naked eyes, by looking at the tubes of the original image and also with CRISPectra's expression graph, we can go through each condition and assess the quality of experiment. For our experiment here, except for the red plus yellow control condition where the red gene maybe could have expressed a little bit more, overall we can conclude that it is a successful experiment. Besides just looking at the bar graphs and observing the red and yellow pigmentation levels from CRISPectra, there's a more informed way for us to determine how CRISPR performed for our experiments. I'll now talk about 2 metrics that can help us assess our dual color experiment's gene repression capability. The first metric is efficiency, which is a measure of how well the CRISPR system targets and represses gene expression. In our dual color experiment, we will measure the efficiencies for both of the genes involved. We will first calculate the efficiency for the yellow gene. For the yellow gene, we will calculate 2 repression efficiencies, one for the yellow targeting condition and one for the both targeting condition. For the red gene, we will also calculate 2 repression efficiencies, one for the red targeting condition and one for the both targeting condition. In total, we will compute 4 values. We will now go through the yellow calculations. For the single targeting efficiency for yellow, we are measuring the level of yellow repression when both genes are expressed, but only the yellow gene is repressed. So as seen in this equation, we will divide the yellow value of the yellow targeting condition in tube 5 by the yellow value of the control red plus yellow condition in tube 3. This ratio provides us with the percentage of yellow gene expression remaining when only yellow is targeted. This ratio is subtracted by 1, and this value will be the percentage decrease, or effectively efficiency of repressing the yellow gene in the yellow targeting condition. We also have to calculate the yellow repression efficiency for the both targeting condition in tube 6, where both genes are simultaneously expressed and repressed. This is important to note too, as repressing red as well in the same reaction might affect the yellow repression efficiency. As seen in this equation, we will find the efficiency by dividing the yellow value of the both targeting condition in tube 6 by the yellow value of the red plus yellow condition in tube 3, and have this ratio subtracted by 1. Now, based on our results from the experiment, we'll go ahead to calculate both efficiencies. Take a minute to verify these results. So for the single targeting efficiency, we obtain a value of 0.917, or 91.7% repression, the yellow gene. For the both targeting condition, we obtain a value of 0.996, or 99.6% repression of the yellow gene. We define a good repression efficiency as anything above around 65%. So as you can see, in our experiment, we achieved high yellow repression. Now you know how to calculate the repression efficiencies for a given gene. I'll go ahead and let you do the same for the red chromoprotein. Please adapt the equations from the yellow calculations and compute the efficiency for the red targeting condition and the both targeting condition for red. Pause this video and compute the red efficiencies. Okay, so now I assume you have calculated the 2 red efficiencies. Here are the 4 efficiency values for yellow and red repression. And great job if you correctly calculated the two red efficiencies as seen here. Now you have quantitatively measured how well your CRISPR experiment has repressed both genes. We will move on to the next metric, specificity. Besides calculating repression efficiency for each gene, we also need to take into account the level of crosstalk repression between each gene. For instance, we want to know if the yellow gene is also repressed inadvertently when only the red gene is supposed to be repressed in the red targeting condition, or vice versa. We will now calculate the specificities for both the red targeting and yellow targeting systems, and I will go through the calculation for the yellow targeting system as an example. To find the specificity of the yellow targeting system, we will have to look at the red values because we are trying to minimize crosstalk and make sure that the red values don't change when only the yellow targeting CRISPR system is added to the reaction. So as you can see in this equation, we divide the red value of the yellow targeting condition in tube 5 by the control red plus yellow condition in tube 3. Ideally, this ratio should be close to 1, meaning yellow CRISPR is highly specific and does not have any off-targeting effects in repressing red as well. So as we can see, once again, in the red and yellow values we obtained from our CRISPRkit experiment and computed by CRISPectra, and the equation I just showed you, we get a value of 1.585, which is a staggering 156%. If the value is anything above 100%, we'll simply adjust the value to 100, which means that the yellow targeting CRISPR system is highly specific and no crosstalk or off-targeting effects are observed. Again, a good specificity is defined as anything above around 65%. Once again, based on the equation I provided, please adapt it to find the specificity for the red targeting system. Pause this video and give yourself some time to calculate this value. Welcome back. So here are the equations and values for both specificities. Now, you have effectively calculated the level of crosstalk between both genes. From these results, we can conclude there is high specificity for both the red and yellow CRISPR targeting systems. Finally, congrats on finishing a dual-color CRISPRkit experiment. This may be many of you guys' first hands-on exposure to CRISPR, and you have also learned how to analyze the results quantitatively. Truly a complete start-to-finish endeavor. Hopefully, after this experiment, you now have a much better understanding of CRISPR and gene expression modulation. Finally, please like and subscribe and visit our website to learn more about CRISPRkit.